did see that you turned in yours as well, and I'll go back and I'll get those updated. Okay, so ladies and gentlemen, we're kind of, I mean, we're saying the same thing. We're still dealing with bath bombs and the productions of the gas. But what I want to do real quick, I want to ask some very basic questions for you. Hema, how are you doing today, young lady?
I'm doing good.
Right. So last week, we explored the individual ingredients of the bath bombs. We are trying to find out what is causing a production of gas. Did we see any kind of gas production when we tested the individual components of the bath bomb?
Yeah, we did.
We
Yeah,
did.
I think like on one of them, like they fizzed a lot. On one
So
of them.
if you go back and look at it in your notes, which individual ingredient with water fizzed?
Well, in citric, if you put the citric acid in the water and then mix it up, and then you put the baking soda in the water, it'll fizz.
Okay, well now that would be two different ingredients now, wouldn't it?
Oh, yeah. I think the citric acid fizzed up a little bit.
Okay, by itself, let me see.
Yeah, I think so. By itself.
I think it was the baking soda that fizzed a lot.
None of them fizzed except citric acid and baking soda together.
Yeah.
All right. Ugh.
And the lemonade is temporary.
Yeah, so but I mean my question was talking about individual ingredients. So citric acid and water. I put it in there. It dissolves. But there is no fizzing. So it wasn't that one. And if I get baking soda in water, this is a different beaker right here. And I put the baking soda in there. And same kind of thing. The baking soda dissolves in the water, no fizzing. So we should have seen, it's all right, Daniel. It seems to happen quite a bit nowadays, technical problems. And I'm sorry, I don't know what's going on, Jagadish. We seem to be, I'm experiencing some technical difficulties. That's why class isn't going to be real long today. I'm going to give you a couple of videos to watch. But by themselves, no one ingredient produced a gas. I mean, they dissolved, sure. They separated, sure. But none of them really created anything different. Now, citric acid and baking soda, and that fizzes. Okay, so we learned this week when I take two ingredients, either citric acid or I take lemonade and I mix them with baking soda, I get bubbles. Now, I will get more fizzing with citric acid than I will get with lemonade. Perneath, do you have any idea why I might have got a bigger reaction from citric acid than I do from lemonade.
Maybe because citric acid is more like has more powerful chemicals. May I answer?
Kind of, but not quite. Jacob, give it a shot.
It's because citric acid is raw, and in the lemonade, it has a bunch of other like ingredients to it.
Okay, you're kind of in the same. Both of you are not that far off, but there's a word that we're really not focusing on yet. Creedy, any idea?
Citric acid is a type of acid.
Right.
And so like lemonade, it's not really like an acid, and so maybe that's why, I guess.
Look at my picture. What do we see on the container?
Lemon.
Lemons.
Lemon.
Lemons are a citric fruit. Oranges are citric. Limes, tangerines, tangelos, pineapples, and there's some others, but those are our main citric fruits. Citric acid comes from citric fruits. So Jacob kind of said it, that there's other things in the lemonade. Well, yes, there's other things in there, and there's nothing extra in here. This is concentrated citric acid. This is like taking the acid out of lemons, limes, oranges, and this is just the citric acid. This is nothing else with it. So this is a concentrated form of lemon and limes and oranges and tangerines and all that other stuff. So that's the difference. One has a lot more. How many of you have ever ate an orange or a lemon or a lime and it's really sour? Right? That is, being sour is a property of acid. Okay, so when you bite into an orange and it's really sour, it's because the acidic content is greater. Chopper, you have a question or a comment?
Oh, I was raising my hand for the if you've ever eaten orange and it tasted sour.
Okay.
But then my hand didn't show up, and I was mesmerized.
Well, it was kind of lost in space. That nebula behind you, I think, was sucking it in. Okay. So, Juliana, how you doing, young lady?
I'm doing well.
Good to hear. Now, Juliana, so we know that lemonade and citric acid both contain citric acid. I mean, they're both a type of acid.
Mm-hmm.
Why is it, though, that they react with baking soda?
Can you please repeat? You kind of went out and in at the same time.
Okay. Why does citric acid react with baking soda?
Because of the chemicals inside of it.
Okay. Fair enough. I mean, that's true. Harrison, any idea? Anything you might want to add to that you might know?
Not really, no, sir.
Okay. Does anybody know? Without Googling it.
Maybe it's because when the citric acid dissolves, a byproduct of like that reaction is a gas. So that's why it fizzes.
Okay. Yeah, I mean, it's producing a gas. This is true. All right. So let me think of
Mr. Schillinger?
yes.
Is it because of like the pH level of like citric acid and like lemonade and baking soda? Because like citric acid is like highly acidic, and so is lemonade.
Okay. So yeah, now Shrieker, I'm not accusing you of anything. Did you look
Like
that
on
up?
the level.
Did you look that up, or is this going off your own knowledge?
Oh, this is off my own knowledge.
Okay. All right. Very good. So we deal with a scale. This is the pH scale. Capital P, little h. So acid. 0 is your most acidic. Actually, I don't know if it truly goes to 0. It might just go to 1. I might be mistaken there. But it goes all the way to 14.
Schillinger?
Yes.
Isn't it a lowercase p and then capital H?
You're right.
Okay, yeah.
My apologies. Keep me honest. Please, always keep me honest. You know, you get senile like me, and you start making these mistakes. And it is the acidity goes to 1. So if I have an acid, the strongest acid is a number 1, and water is another number 7. Shrieker, I don't want you to answer this. I want Viraj, see if he can tell me what it is. What is the opposite side, Viraj, from an acid? What would be over here on a pH scale of 14?
Can you repeat that? You're kind of laggy.
What is the opposite pH from an acid? If acid is a 1, what do we call something that has a pH level of 14?
What's the scientific term?
Right. From 1 to almost 7, this is acids. What's 7 to 14? What is that category?
I don't really know the term for it, but like.
Okay. Daniel?
I don't know.
All right. Sid's biting at the bit over here. What is it, Sid?
I thought it was base.
It is.
Acid, then base.
Acids and bases. So, story time. Yeah, me and my stories. I always got stories. It's kind of hard to see, but on this arm right here, I have a bunch of scars. And when I was in my 20s, I was working on a car. I was underneath the car. My hand was up inside the exhaust manifold. I was putting something called headers on the car. We were charging the battery with a rapid charging, a big, powerful charging unit to charge the battery. And we overcharged the battery. The battery split open, and sulfuric acid dripped down my arm. Burned it really bad. Oh, it hurt. It hurt like my arm was just completely on fire. So we got a box of baking soda, and we poured it all over my arm. my arm fizzed. I mean, it just foamed. My whole arm foamed up. Anywhere where that acid was at, it foamed up. Made it feel better. Didn't make the pain go away, but it helped. It got rid of the acid because we took something that was very acidic and we mixed it with the base and they canceled each other out. Okay. Now, flip side of that, go about 10 years in the future, I'm in the Navy. I am stripping wax off of floors in a barracks. And we're using this floor stripper that is non-toxic. It's not supposed to hurt. You know, you can put it all over your hands if you want. Nothing's supposed to happen. So I'm down on my hands and knees. My jeans are soaking wet from this stuff. And we run out. So I asked the guy that I'm working with, like, go into the cleaning closet, get some more floor stripper for me. So he comes back with this bucket and he dumps the bucket on the floor. And I'm working along and my leg starts to burn. And I go outside, I roll up my pant leg, and about this much from my knee down my calf is charcoal black. He poured something called sodium hydroxide on the floor. It was a floor stripper, but something that you're not supposed to let come in contact with your body. It was a base, a very strong base. And they took me to the hospital and they poured acid on me to neutralize it. So what we are seeing is baking soda is a base. Sodium bicarbonate. It's the sodium is an alkaline, and the alkaline is a base. It's on the opposite end of acids. So when they come together, they're reacting. And they're producing some kind of gas. And they're making water. Okay. So we're going to stop right there for a second. And we know that when we mix the citric acid and the baking soda together, we know a gas is produced. You guys are pretty smart. I know a lot of you are, you Google questions, and that's awesome. It makes self-discovery a little bit different because, you guys can look up the answers. And I'm not saying there's anything wrong with that at all. But what we need to do is we need to start investigating the gas. And if you have not already figured out what the gas is, don't Google it. And I don't want anybody necessarily to say what it is right off the bat, okay? So, Elijah, how you doing, sir? Good. Sir, I'm going to play with a little fire right now. Fire. Fire. I like fire. It's pretty.
Same. I love
Fire. Fire. Okay. Anyways, I lose myself a little bit. So, Elijah, I'm going to drop a bath bomb. Actually, before I do that, do you think, Elijah, that I could put a match into this flask and the match still burn? What do you think, sir?
Possibly.
Oh, come on now. Give me a yes or a no.
No.
Possibly is a is a wishy-washy answer and you're not willing to commit. So Elijah says no. Austin? Are you there, Austin?
Yeah.
What do you think?
Wait, I'm confused on what's going on.
Well, what I was just saying is I'm going to take this flask. I'm going to light this match. Do you think I put it in the flask and the match still burn?
Yeah.
Okay. And I see Nolan with his hand up over there. What do you think, Nolan?
I think it won't.
Okay.
And can I say why?
Sure.
after?
Go ahead. Tell me why.
I think it won't because the flask the glass is covering the air inside from the rest of the atmosphere, so there won't be any oxygen, which is fire's fuel to like keep the match going.
Okay.
I
Juliana?
totally agree with Nolan.
Yep.
I agree with Nolan because, like he said, oxygen is the fuel for fire. So if you put it in quickly, it's probably going to burn out because the oxygen is being taken away. And because it doesn't have a direct access to oxygen, might not burn as bright, or it might go out entirely.
Okay. Shrieker?
I think
I
I
agree.
think it would still like burn like for a little while, not as long, because like it still has access to oxygen. Like it's unless you're closing the top of the flask, I don't think like it's gonna burn.
Okay. Abigail, you said something?
I agree with Juliana
Okay.
because if you put it in and you don't like hold it and you drop it, when it hits the ground, it's gonna burn out. But if you just hold it there, all the oxygen doesn't directly hit it.
Okay. So, and last one, Chopper?
Something that's kind of different is technically if you were able to hold it by the fire end without hurting yourself or the fire and put it in that way, it might not burn out, but you can't do that.
I'm not going to do that.
Fire.
All right.
Yeah.
Let's give this a shot. So my match is burning. I hold my beaker up and it burns. It went out the second time. So what was being said is relatively correct. But the thing is, right now, this is a new flask. That flask is filled with air. It is burning until the air is used up. Okay? But you can see that especially if I go right to the edge, the match continues to burn, right? And now, just for sake, I've got a bigger flask here. Same exact thing. And this flask has some water in it. All right. So what I'm going to do now, Jagadish, I'm going to test the gas that we are creating with a bath bomb in water. So, Jagadish, can you hear me? Okay. Sahana.
He asked, did you say my name?
Who said that? Oh, wow, okay. My scroll bar was not going down. Now we go. Okay, so Jagadish, what do you think will happen if I put this bath bomb into the flask and try to put the match inside of it. Just in the lip.
I have a suggestion. I actually have a question. Are you putting the bath bomb in water or just in the flask?
I'm going to drop it in the water and we're going to produce the gas. What I want to know, so basically the gas is going to do one of two things. Actually, it can do a couple more. It could put the match out. It could just let the match burn like normal, or it could intensify the fire and possibly even explode or shoot out a flame. Jagadish, the bath bomb is going to fizz. What's going to happen to my match? So it's going to put it out. So Hannah, what do you think?
I don't really know what to think, but I'm thinking that it'll make the fire bigger because it has like, well, no, I think it will just burn longer since it has more oxygen now.
So there are, let me see here. I want to show you all something real quick before I do this. I'm going to present my screen real fast. All right, come on, work for me, work for me. There we go. Okay. So do you all see the, hold on, let it load up here. Loading, 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 loading.
We can't see it.
Yeah,
You don't see anything?
we can see it.
Okay. So here's a chart of common gases. Okay. It says nitrogen will extinguish a flame, and there's 78% of that in our atmosphere. Oxygen will increase the flame or cause a glowing ember to burst into flames. Argon will extinguish a flame. Carbon dioxide extinguishes a flame. Neon, helium extinguishes a flame. Methane, hydrogen, propane all cause an explosion, will increase the flame. Air will maintain a flame. And carbon monoxide will put a flame out. So it's about 50-50. And these are all common air gases that we deal with. Okay. So I'm going to stop presenting real quick, bring you back to my wonderful face. Scary, sorry. So a couple of you think it's going to go out. A couple of you think might continue to burn. Chopper?
Oh, I just wanted to say that I don't think it is going. I don't think the gas that is made is oxygen.
Okay.
I just won't say that much because.
All right, well, let's put it to a test. So I take my bath bomb. It's sitting on top of my beaker. I'm going to get my match out and get it ready. I'll take a couple matches out. One of these days, I'm going to set the fire alarm off, and they're going to be mad at me. All right, so it's in there. It starts to fizz. So as soon as it goes into the beaker, there we go. It's not even going all the way into the beaker, and extinguishes the flame. So we already know in a closed system, my gas escapes, right? Didn't we experiment with that? You know, we ran the bath bomb with no balloon on it, and I lost mass, right? So as I put the match up to the flask, the gas is coming out, and it extinguishes the flame. Okay. What we are going to move into with this part is we're going to start talking about density. How many people here know what density is? Okay. So what I have for you today is a video to watch. Actually, it's two. One's by Neil deGrasse Tyson, and the other is just a science classroom video that deals with density. Density is simply the amount of mass in a given amount of volume. In the most easiest way to say it, how much stuff is in a given amount of space? That's very unscientific. How much stuff something has in it, right? So we looked at oil and water. Ramchan, what happened when I mixed oil and water?
Whenever you mixed oil and water, the oil would not fall, come apart.
No, but what did the oil do?
So it basically just the olive oil, it would just stay there, and same with the coconut oil, would just sit on top.
Okay, so it just stayed on top, right?
Yeah, it just sat there.
Okay. Arsh, you had something you want to add?
What if like something was combining two things together?
Say that again.
What if I can like bind two things together?
When we combine two things together?
Yeah, or it can be used to like, combine.
I don't. Oh no! I mean that's what oil is.
Oil could
Yes, we used the oil.
used to bind.
We used oil in the bath bombs as a binder. But what I wanted to know was what did oil do with the water? And Ramchan said it.
Float on.
Yeah, it floats on top. So the reason why is oil is less dense than water. So it floats on top. How many people here have ever seen a lava lamp?
More.
You know, they're kind of cool, right? You know, you sit there and you have this stuff that's going up and down inside a liquid. Well, all a lava lamp is cooking oil and water and food coloring. There's nothing super special about this. But what happens at the bottom of the lava lamp, you have a small little bulb, and that gives off heat. As we heat the water, we change the water's density. You turned my light back on for me. Thank you. Really? So as we change the density of the water, the oil will start to sink because we're also changing the density of the oil. And then what happens to something when it heats up? Does it rise or does it fall?
It rises. It rises. Heat rises.
Right. Heat rises, it goes up to the top, it cools, and it comes back down, right? So we're heating both the water and the oil, and they keep just going back and forth with one another. And we kind of see that when we talk about the states of matter. Remember, we went back to the very beginning. If density is how much stuff is in a given amount of space, and the formula for that is actually grams over milliliters, what happens to the molecules of a solid when I apply thermal energy to it, when I apply heat to it? Do they get closer together or do they spread out?
They spread out.
They spread out. So as I heat a solid to a liquid, does my density change?
Yes.
Yeah.
Yeah.
And as I take that liquid and I continue to add thermal energy and I make it into a gas, does my thermal energy continue to change? Does the amount of molecules I have in a given amount of space, does that continue to expand? I mean, decrease, they keep moving away?
So it's more spread out.
Yeah, so my density will keep getting less and less as we heat something up. All right, so we're going to come back to that on Tuesday, and we're going to start using density to help us figure out what this gas is. Now, without saying it, how many people already know what the gas is? All right. There's a good group of you, but some of you aren't saying you know, and that's fine. If you don't know, please do me a favor and don't check. Don't look it up. And for those of you who do know, don't share it yet. Okay? You can help guide the conversation, but don't blurt out what it is right off the bat. Fair enough?
Wait, what is the question?
I wanted to know how many people knew what gas is being created when we mix citric acid and baking soda together.
Okay.
Okay. All right. There are 2 videos totaling 20 minutes for both of them on density. If you think you got density pretty well wrapped up, you don't have to worry about the videos. Okay. If you want to know a little bit more about what density is, give it a try. Watch one of them. Maybe start with a 5-minute, or if you like Neil deGrasse Tyson, who's kind of an interesting guy, watch his video. That one's 15 minutes. And he's going to talk about mass, weight, and density all together. All right? Ladies and gentlemen, have a wonderful weekend.
Bye, Mr. Slinger.
Bye. And Elijah, that's great. I mean,
Bye.
if you think you know, we'll work on it. We'll see where we get with that.
Bye, Mr. Saunders.
Bye, everyone.
Mr. Saunders.
Make sure you get your homework turned in from Tuesday.
Mr. Schillinger,
Yes, sir.
I have a question about the acids and the bases.
Okay.
So, let's say you were saying that, you had, sulfuric acid, right, all over your arm.
Right.
And, they put baking soda to, neutralize it, and vice versa, with the wax and, the flooring thing.
Right.
So, what if they put water on the acid, or what if they put, water on the base? What would happen?
Well, see, it might help reduce the acid, but it doesn't counteract it as quick. Now, with the sodium hydroxide burn, I was in the hospital for a day and a half. They immediately put it was an acid that had silver in it, and I forget exactly what it was called. But the silver iodide, which was part of it, was to help in healing. The acid was to neutralize as quick as possible, but they still put, I think it was 15 liters of saline solution as a dripping down my leg over the next day and a half. And that just helped to stabilize the pH level. Because your body has a natural pH level on your skin of 7.
Okay.
So, but yeah, I mean, it would help. But the thing is, while the base and or the acid is still on your skin, it is still eating away. It's still breaking apart the molecules. So they need to find a way to drop or raise the pH level as quick as possible. Then they'll take less harsh measures. Because if they put too much acid on there, then they're going to flip it and they'll start giving me an acid burn. Does that make sense?
What did you say, Mr. Schillinger? You broke up. You broke up, Mr. Schillinger.
Well, okay, so what I was saying is they're going to use the opposite end. Let's say we're talking about the base burn. They're going to put an acid on there, but not a lot, just enough to drop it closer to 7. They don't want to put too much on there because then they're going to go on the other side and they're going to start giving me an acid burn.
Yeah.
So they only dropped it so much and then they used the water to help neutralize it back down to a 7. And the baking soda is just something my friend did. He just grabbed the baking soda and, he had read about that or he heard about it. I didn't know that at the time. That would have helped.
Oh.
But he just jumped a whole box on my arm and it made it feel a lot better. Didn't stop the hurt, but it made it feel better.
Okay.
And then the doctors just basically gave me some cream to put on it when I finally got to the hospital with it. I had an accident-prone youth. So Elijah, what's up?